Hi everyone, we're going to take the 2.3 section 2.3 notes today, laws of limits. There are quite a few laws that I'm just going to write and expand, so please write these as we go. The first law is the sum law. It says that if you have a limit as x approaches a is some value, of two functions that are added together, the law says that you can split the limit into the sum of two limits. So limit of f of x plus the limit as x approaches a of g of x. So you can split it between the plus sign. Another one is called the difference law. Of course, you can imagine it looks just like the sum law with a minus sign. So the limit as x approaches a of two functions that are subtracted from each other, the difference of two functions, may be split into the difference of the two separate limits. And sometimes doing this makes the algebra a little bit easier. Okay? We have the constant multiplication law, which says if I have a limit as x approaches some arbitrary number of some number times f of x, c is the constant, then you may factor out the c in front of the limit, do just the limit of the function, and then whatever the answer to the limit is, multiply by that constant. Okay. We have the product law. It says that if I have the limit as x approaches a of the product of two limits, I am allowed to split it again and do the product of two separate limits. Okay, we have the quotient law. Quotient law, that's about division. That says the limit as x approaches a of some function divided by some function, okay, may be split into the limit of f of x as x approaches a divided by the limit of g of x as x approaches a, but there's a big if. If the limit as x approaches a of g of x is not equal to 0, because you can imagine if this is 0, then it's something over 0, and we know we can't have that. That's undefined. Okay. Then we've got the power law that says if we have a limit as x approaches some value a, and it's a function, you notice here being raised to some exponent, the power law says you can do the limit without the power. Like you can figure out the numerical answer for the limit and then raise that numerical answer to that power. They are one and the same. Then we've got the root law. It's kind of the inverse of the power law. It says if I have a limit as x approaches a of some function to the nth root, then what I can do is I can do the limit of that function without the root, but then take my entire answer for the limit and nth root it. Then we've got the limit of a constant is a constant. This is super important here. Basically, limit as x approaches a, some number, of some number. The function is a constant, like 5. Then the answer is 5. What is the rationale? Well, if this is f of x and f of x is equal to c, that means it's a horizontal line, like y equals 5. For example, right? Constant. Okay. What if I say find the limit as x approaches 2 of the function 5? What is the function 5? It's this horizontal line. Here it is. Remember, what does it take for a limit to exist? Well, the left-handed and the right-handed limits have to be the same. So as I look at this, incoming from the left and incoming from the right, they both meet up at y equals 5. So the limit of a constant is the constant. Number 9 is called, this is really super important, is called the direct substitution law. Okay, and it says that if I have a limit as x approaches a of f of x, then the answer of the limit is going to be f of a. But there's a big if. If f of a can be found algebraically. Okay, so sometimes you'll have a function here. So I'm going to talk about this rule a lot here, this law. Sometimes you're going to want to get the answer to the limit by plugging in the a into the function. Okay, let's say you don't have a graph, so you can't look at it. You can't see it incoming from the left, and you can't see it incoming from the right. But this law says you can also find the answer to the limit with using algebra. Just plug in this number into the function. But what if you have a function where you plug in the a and something becomes undefined? Well, if that happens, if you try to plug in a into f of x and you see that you can't, I'm going to do this one in red, then try either factoring, simplifying, or multiplying by the conjugate. Okay, so I'm going to demonstrate this one with a few examples. Ready? All right. Here we go. So example 1. What if I say find the limit as x approaches -2 of x to the 4th power minus 2 over 2x squared minus 3x plus 2. Now, I think I've said this a lot already, but I'm going to continue saying it a lot. What's it going to take for a limit to exist? Well, in order for a limit to exist, the limit incoming from the left as x approaches -2 from the left, and the limit as x approaches to -2 from the right, with a little plus sign, they both have to meet up at the same value. They both have to have the same answer in order for this limit to be that. But the problem is, I don't know what this graph looks like. And quite frankly, I don't want to graph it just to get the answer to the limit. Well, the direct substitution law says you can also get the answer to the limit by plugging in the number into the function. This is f of x. So what we can do is try -2 to the 4th minus 2 over 2 times -2 squared minus 3 times -2 plus 2. Let's see if this is going to give us an answer. If it gives us something undefined, like something over 0, then we can use it as a strategy of factoring, simplifying, or multiplying by conjugate. Let's see. -2 to the 4th is 16 minus 2 over -2 squared is 4 times 2 is 8. This is plus 6 plus 2. This is 14 over 16. You guys, the answer is 7/8. This is the answer. And we just leave it. We're done with the problem. So basically, whatever this graph looks like, I have no idea. I do know that as I approach -2 from the left and the right side, as I approach x equals -2 from the left and the right side on this graph, they will meet up at a y value of 7/8. Okay, let's do another example. So that's direct substitution. That worked. So now let me give you this problem. What's the limit as x approaches negative 3 of x squared minus 9 over 2x squared plus 7x plus 3? Well, let's see. Let's try. We always want to try to plug in and hope, like this one, we can just get a numerical answer. Let's see. If I plug in a negative 3, I get 2 times negative 3 squared plus 7 times negative 3 plus 3. Let's see what the answer is. This is 9 minus 9 over, that's 9 times 2 minus 21 plus 3. You know what? I believe that gives you 0 over 0. We call this an indeterminate form. You cannot accept that because 0 over 0 is undefined. So, like I said at the bottom of the notes on this page, if you try to plug in an a into f of x and you see that you can't, so we just saw that we can't, then try either factoring, simplifying, or multiplying by the conjugate. Well, let's see. I think I'm going to try to factor because I see the difference of 2 squares. So this is going to become the limit as x approaches negative 3. How does x squared minus 9 factor? It factors into x plus 3, x minus 3. And then the bottom one will factor into 2x plus 1. And am I doing it right? Yeah, x plus 3. Let's just check that. Yes. So these two cross out. Now I'm left with the following limit. The limit as x approaches negative 3 of x minus 3 over 2x plus 1. You guys, it is super important for you to not drop the limit notation from each step to the next. Do not drop it, otherwise it's wrong. So now we can try direct substitution again. Let's see if it'll work this time. So if I plug in a negative 3 into my reduced equation, I crossed out these factors. This is called the reduced equation. I'll get negative 3 minus 3 over 2 times negative 3 plus 1, which is negative 6 over negative 6 plus 1 is negative 5. The answer is 6 over 5. That is our limit. And what basically that means on this graph is, that as I approach negative 3 from the left and from the right, incoming to negative 3 from the left and the right on this graph, whatever it looks like, they are going to meet up at a y value of 6 over 5, but it's not going to be an open circle there. I mean, it's not going to be a filled-in circle. There's going to be an open circle. Remember, a limit can exist. Oh, this is not negative 3. Oops. Scratch that. Let's do negative 3 on this side. I don't know what the graph looks like, but pretend that this graph looks like that. And this is 6/5. Okay, positive 6/5. So the graph is doing something like this, where the limit incoming from the left is equal to the limit from the right. They go to the same y value. The y value doesn't exist there, but they do approach the same 6/5. Okay, so the limit is 6 over 5. Let me do 2 more. So example 3. What if I get the limit as x approaches negative 2 of x plus 2 over x cubed plus 8? Well, direct substitution. Let's hope this works. If I plug in a negative 2, I get, what do I get? I get 0 over negative 2 cubed is negative 8 plus 8 is 0. Again, that's indeterminate. So I can't accept this as an answer. I have to either, what was it? Factor, simplify, or multiply by a conjugate. Let's see. So how do I factor this? Can I factor this? I sure can. It's called the sum of 2 cubes. So x plus 2 is not factorable, but x cubed plus 8, let me switch that out for a different color so you can see. This is the sum of 2 cubes, which if you don't remember the formula, you're going to have to look that up. Factors into x plus 2 times x squared minus 2x plus 4. All right. Watch what happens. You're able to cross out the x plus 2's. There's a times 1 up here. So now I have the limit as x approaches negative 2 of 1 over x squared minus 2x plus 4, which I think direct substitution is going to work now. I'm going to have 1 over negative 2 squared. I'm plugging in this negative 2 into these x's. Minus 2 times negative 2 plus 4, which is 1 over, what is that, 4 plus 4 plus 4 is 12. My limit for this problem as x approaches negative 2 is 1 over 12. And you can bet your bottom dollar that 1 over 12 is definitely the y value that we get on this graph, where as you approach negative 2 from the left and the right, so at negative 2, this is the y value, but it's not, it doesn't actually exist as negative 2 comma 1/12. There is a hole. There's going to be a hole at negative 2 comma 1 over 1/12. But the limit is 1/12. Okay, I have one more example. So example 4. And that example is the following. Let's see, what's the limit as x approaches 0 of rad 1 plus x minus rad 1 minus x over x? So let's try plugging in a 0. The first thing you always want to do is cross your fingers that this is going to be a problem where direct substitution is just going to work the first time. So let's go. We have rad 1 plus 0, I'm plugging in a 0, is 1, minus rad 1 minus 0 is 1 minus 1 over 0. 1 minus 1 is 0 over 0. So if I have an indeterminate, I have to manipulate this. Okay, so the things we can do are simplify, factor. So there's no way you can simplify this. There's nothing you can do. You could factor, but how do you factor rad minus rad? You really can't. So there's one more strategy left, which is to multiply or divide by a conjugate. So if you look at this and you remember what a conjugate is literally the same binomial. This is a binomial, something minus something, but with a different sign in the middle. So the conjugate would be 1 plus x plus rad 1 minus x, all over the same thing. Okay, so the plus makes it the conjugate. Everything else is the same. The 1 plus x and the 1 minus x don't change. So then we multiply those conjugates out. And the beauty of conjugates is when you FOIL, that middle F-O-I-L, the O and the I cancel out. So if I FOIL these out, okay, FOIL, I'm going to get the following. I'm going to get, in conjugates, the O and the I cancel out. Rad 1 plus x times rad 1 plus x, which is just 1 plus x. Negative times positive is negative. And then I'm going to get rad 1 minus x times rad 1 minus x, which is in parentheses 1 minus x. The bottom two that I'm multiplying this times this whole expression, I'm just going to write x times rad 1 plus x plus rad 1 minus x. This times this. Okay, so then I start simplifying and see. Cross my fingers, it's going to work. Distribute that negative. 1 minus 1 is 0. X plus x is 2x. All over x, parentheses, rad 1 plus x plus rad 1 minus x, close parentheses. And then I notice, oh, this fraction is reducible. This x and this x can cross out. So now I have a whole new limit problem. The limit as x approaches 0 of 2 over this set of parentheses, rad 1 plus x plus rad 1 minus x. Watch what happens now. The 0 is going to be basically something that I can plug in. 2 over rad 1 plus 0 plus rad 1 minus 0, which is 2 over rad 1 plus rad 1 plus rad 1, which is 2 over 1 plus 1, which of course is 2 over 2, and the answer is 1. Okay, so basically just recap. If direct substitution doesn't work, you can try factoring, simplifying. Usually with rads, the multiplying by the conjugate will work. And if all that fails, you're going to have to rely on either the graph or a table of values, which we shall visit at a different time. Table of values is basically the last resort. If nothing else here works, factor, simplify, multiply by conjugate, you want to try to graph it. And if it's too hard to graph by hand, then you'd go to table of values. And we try to never do that, almost never do that, okay? But for now, we're going to stick to those. Okay, and that's the end of the notes. Thanks for watching.